Welcome to Relaxing Sleepy Science. In the dark, a small light flickers into existence. This is not the birth of a star, nor the first spark of a candle. The beginning of the universe itself, 13.8 billion years ago, marks the start of a system that would take a long time and change the universe. The universe is quiet, a space filled with energy and possibility. It's a place waiting for something to happen, a silence that waits for the first sound. Stillness, the vastness that comes before anything happens, where time is just starting to be understood. As the universe grows, it becomes cooler, like the breath of a giant, a slow, steady movement that stretches far in a short time. The earliest and fastest growth phase, driven by an unseen force, pushes the universe outward quickly. In this process of creation, tiny changes in energy appear, like ripples on a calm surface, small disturbances in the world around us. These are the beginnings, the first signs that will one day grow into galaxies, into the structures that fill the sky. The universe continues to grow, to become cooler, a slow, steady change, a timeline moving at a very slow pace. As it does, particles form and then disappear, leaving behind a mix of basic building blocks, a collection of fundamental parts. The universe's earliest mix, a place where the first parts of creation will come from, is where neutrinos separate, leaving a mark on the background light. They're like messages, carrying information about the universe's earliest moments across time. The universe is a large, quiet place, and on this place, galaxies are about to start. The process begins with the pulling together of early gas clouds, influenced by those tiny differences in density. It's like the hand of a guide, leading the movement of matter as it comes together to form the first galaxies. The life of galaxies starts with their creation from the quiet of the early universe. It's a process that takes a very long time, a story played out across the universe. But this is just the start. The universe is a large, quiet space, and the story of its galaxies is only beginning. In the early universe and expansion, the universe's story starts to form, a system that will continue to unfold. The universe now stands as a vast, still expanse, beginning its next chapter. Cosmic forces guide the expansion of matter, setting the stage for rapid growth. This is the earliest phase of the universe's expansion, a time of quick growth that occurs within a very short time after the beginning. Imagine the universe as a vast balloon filled with a special substance. As the balloon grows, so does the universe, driven by a force that pushes space apart. This force stretches the cosmos quickly, unfolding the universe's vastness. During this time, the universe is a quiet space, a stillness waiting to be filled. Within this stillness, a quiet promise of what's to come begins to take shape. Tiny changes in the special substance, like the first flickers of light, are the beginnings of the structures we see today: galaxies, clusters, and groups of galaxies. As the expansion continues, the universe grows constantly, like a gentle breeze spreading through space. It is a time of steady growth, like a nebula stretching into the empty space around it. The universe is a canvas, and this growth is the first step in creating the cosmic picture that will follow. The early universe begins to form galaxies, a natural force, gravity, pulling matter together, shaping the cosmic background into something more complex and beautiful. The quiet of the early universe is about to change, and the universe is ready to begin its next steps in the ongoing process of creation. In the cooling breath of the cosmos, the universe expands, a silent canvas awaiting its first brushstrokes. The inflationary epoch wanes, and with it, the steady, unseen force that has pushed space itself apart. Now, the fabric of reality begins to contract, ever so slightly, as gravity hums its soft song. The stillness is no longer empty, but teeming with potential. Quantum fluctuations ignite within the inflaton field, the first embers of what will become the fabric of the cosmos. These minuscule disturbances are the seeds of galaxies yet unborn, galaxies that will move in the cosmic movement of light and dark matter. As the universe cools, it begins to change. The quarks and gluons that once danced in a fiery plasma, locked in an intricate waltz, start to slow. They pair off, these fundamental partners, coalescing into protons and neutrons, the building blocks of matter. The universe, once a sea of energy, becomes a vast ocean of particles waiting for the next act to begin. Neutrinos, those ghostly messengers of the early universe, decouple from their brethren. They slip away, leaving an imprint on the cosmic microwave background, a record of their fleeting existence. They are the first to leave, the first to escape the cosmic prison, traveling freely through the universe, untouched by time or matter. In this new, cooler universe, matter and antimatter particles appear. They move together, a waltz of annihilation, leaving behind a burst of energy, a brief flash. The universe is filled with light, a momentary, intense glow, before settling once more into stillness. This is the beginning of the universe, the first light of creation, and it is a moment of great beauty. The stage is set, and the universe is poised for the next act. Baryogenesis, the mysterious process that will lead to the dominance of matter over antimatter, is about to begin. The cosmic guide is poised, strings in hand, ready to draw the first threads of life into place. The stillness is about to give way to the movement of the galaxies, the cosmic music that will fill the void with light and sound, with life and time. The universe is ready, waiting, on the brink of a new era. The hot Big Bang and subsequent phases await, ready to take center stage in the ongoing cosmic system. In the early moments of the universe, around 10-point seconds after the Big Bang, a change begins. This process marks the shift from energy and matter, preparing the stage for galaxy formation. The universe undergoes a fundamental transformation in its basic forces. Until now, the strong and electroweak forces were interconnected, but as the universe expands and cools, they start to diverge. The electroweak force becomes distinct, revealing the forces that shape our cosmos. During this period, a dense mix of quarks and gluons fills the universe. This is a brief interval where quarks move freely, guided by the strong force. It is a time of energy and potential, where the universe's fundamental building blocks are forged. As the universe cools, the strong force takes over, binding quarks into protons and neutrons. This marks the beginning of a new phase, where particles form the basis for stars and galaxies. The W and Z bosons, now separate, interact with other particles. They create and destroy particles quickly, contributing to the universe's dynamic activity. This change is a pivotal moment in the universe's development. It sets the stage for the structures that will form galaxies, stars, and planets. The universe continues its process, poised for the next step in its evolution. The universe, now a few moments old, begins to change. The stillness, once absolute, is now a series of interactions guided by the strong force. Protons and neutrons, the building blocks of matter, start to form, marking the beginning of the Hadron epoch. In this cooling cosmos, the electroweak force begins to shape the environment, connecting particles in a complex cosmic pattern. Special particles, once unified, now interact with others, creating and breaking down particles at a rapid pace. The universe fills with energy and light, a prelude to the formations that will come to define it. A new force starts to influence the environment, the electromagnetic force guiding the interactions of charged particles, setting the stage for the next phase in the cosmic process. This shift marks a significant turning point as the universe begins to take on a more defined structure. Meanwhile, neutrinos, those mysterious particles, start to move away from the rest of the matter, traveling freely through the cosmos and leaving an imprint on the cosmic microwave background. This marks the beginning of the end of their direct role in the cosmic process, as they continue their system, albeit in a less active capacity. The universe, once a hot, dense collection of quarks and gluons, is now a cooling cosmos filled with protons, neutrons, and many other particles. The environment is prepared, and the universe is poised on the cusp of a new phase, its energy and potential waiting to be unleashed. In the cooling cosmos, protons and neutrons, once locked in the active process of the quark epoch, begin to slow. Their high energy wanes, and they start to feel the pull of the electromagnetic force, a new interaction that connects them. This force, subtle yet powerful, weaves connections, linking particles in a complex cosmic network. The universe, once a dense mixture of energy and light, is now a cooling process of potential, ready for the next phase in its ongoing evolution. The universe's energy and potential are poised, awaiting the next phase in its unfolding. In the cooling cosmos, a new dance begins. Protons and neutrons, once moving together since the start of the universe, begin to interact. They've been working together since the beginning, but now, as the cosmic environment cools, their paths begin to change. The opening act of Big Bang nucleosynthesis introduces chemical processes, laying the groundwork for the universe's elemental evolution. Neutrons, once common, start to feel the effect of change. They've been stable so far, but now, as time passes, they begin to resist time's passage. Some of them, around 25% in fact, become protons, leaving behind a helium nucleus and an electron. This marks the universe's first step in forming elements, a process that will continue to unfold. Meanwhile, protons, once free, join together. They begin to notice the neutrons change and decide to stay together to avoid the same change. Two protons, with a little help from a neutron, form the nucleus of a helium-3 atom. This marks the universe's first stable structure, a milestone in the formation of atomic nuclei. But the universe doesn't stop at helium. It's a natural process, and it's just beginning. Helium-3 atoms, in turn, combine with other helium-3 atoms or with hydrogen nuclei to form helium-4. This marks the universe's first step in forming the most common element in the cosmos. As the universe continues to cool, this process of forming nuclei becomes more complex. Deuterium nuclei, created from the union of protons and neutrons, begin to join and form helium. The universe's first step in forming heavier elements is underway, but it's not just about helium. Lithium nuclei, created from the joining of helium and hydrogen, begin to form. This marks the universe's first step in forming the lightest metals. The universe, in its steady pace, waits for these nuclei to form, a natural environment of potential, ready to create the building blocks of stars and galaxies. The universe cools further, and this process of forming nuclei slows. The cosmic environment, once a hot, dense mix, is now a cooling cosmos. The stage is set, and the universe is ready for the next phase in its system. It's a natural environment of energy and potential, waiting for the next step in the ongoing process of the universe. The universe's evolution is poised to take a new turn as it moves towards galaxy formation and the emergence of complex structures. In the quiet, boundless expanse of the early universe, a cosmic movement of particles begins. Movement of protons, neutrons, and electrons, each moving in patterns, like comets tracing paths through the night sky. This is the cosmic movement of the Big Bang, the first step in the story of the universe. As the cosmic sea cools, it slows its movement, but it does not stop. A force driven by the very fabric of existence, a force that will shape the cosmos for eons, begins to exert its pull. In this calm, a new force starts to exert its influence, a force that will create the structure of the universe in ways we are only just beginning to understand. Gravitational collapse, a cosmic force that brings matter together, starts to take hold. Gas clouds, vast and sprawling, begin to contract under their own weight, like nebulae expanding in reverse. These are not mere clouds of gas, but the seeds of something greater, something that will change the face of the universe forever. Yet, these clouds are not alone in their movement. An invisible force guides their movements, a force that will play a role in the creation of the first galaxies. This force is dark matter, a substance that exists in the cosmos, its presence known only through its influence on gravity. Dark matter does not move like the gas clouds. It is a silent, unseen force, its movements subtle yet powerful. It does not interact with other matter, but it shapes it, like a gravitational pull that bends the path of light. It is this unseen force that provides the gravitational wells where gas clouds can collapse and form the first galaxies. But the movement of the universe is not yet complete. As the cosmic sea continues to cool, another force begins to exert its influence. This force is dark energy, a mysterious force that pushes the universe apart like a wind blowing through the cosmos. It speeds up the expansion of the universe, allowing galaxies to form structures on larger scales over time. And so, in this vast, calm expanse, the first galaxies begin to form. They are not yet the majestic spirals or ellipticals we see today, but they are the seeds of what will come. They are the cosmic background radiation, the first light in an otherwise dark universe, a sign of the beginning of a new chapter in the ongoing story of the cosmos. As the galaxies form, they begin their own movement, a cosmic movement that will continue for billions of years. This movement is not one of chaos, but of order, a harmonious pattern played out against the backdrop of the expanding universe. The movement brings us from the earliest moments of the cosmos to the present day, a movement that is as beautiful as it is vast, as calm as it is infinite. The cosmic sea, once a hot, dense collection of particles, becomes a cooling cosmos filled with the first galaxies. The stage is set, and the universe is ready for the next step in its ongoing story. The cosmic movement of galaxies has begun, and with it, the story of the universe continues to unfold. In the quiet of the cooling cosmos, a new power begins to affect the universe. It is not the pull that brings matter together, nor is it the push of dark energy that moves the universe apart. This power is subtle, hard to discern, yet still very strong in its role. It is the structure made by dark matter, a way to help form the first galaxies. As the universe grows, the neutrino background, a leftover from the early universe, spreads out, carrying the systems of creation. These neutrinos, once part of a hot mix, now move freely, their paths influenced by dark matter. They move through space, guided by this unseen force. The background radiation, a sign of the Big Bang, cools more, dropping below the level needed for nuclear fusion. In this cool, dense mix of protons and neutrons, the first light elements are created. Helium and lithium, the basics for the first stars, are formed in a process called Big Bang nucleosynthesis. This marks the beginning of light in a dark universe. Meanwhile, the structures of dark matter grow deeper, their influence spreading through space. They help gather gas clouds and keep them stable, preparing for galaxy formation. Each structure is unique, reflecting the early universe's changes. As gas clouds collapse under their own gravity, drawn together by dark matter, they start to spin. They create a movement, swirling as the universe has always done. This is the start of the first galaxies, which will evolve into the shapes we see today. Galaxies, once formed, are not isolated. They are linked by a network of dark matter threads that stretch across the universe. This structure helps galaxies move through space. The movement of galaxies begins. It is a process of order, creating a pattern as the universe expands. The universe is poised for the next step in its story. The movement of galaxies has started, and the universe's story continues. The effect of dark energy, which will speed up the universe's expansion, is not yet clear. Right now, dark matter's structures guide the first galaxies in this vast, quiet space. The process is just beginning and will continue for billions of years, shaping the universe as we know it. In the deep silence, a new force begins to appear, its effect moving through space. Dark energy, a mysterious thing, starts to show its influence, its changes quiet yet important. It is not a force that pushes or pulls, but one that slowly moves, like a soft breeze moving through space. As the first galaxies start to form, they come together because of the pull of dark matter. The ancient light from the beginning of the universe starts to stretch, its colors changing as the universe grows a little faster. This is the slow movement of dark energy, the start of its effect on how galaxies change over time. In this new time, galaxies are connected by the soft threads of dark energy, like the tails of comets moving through the dark. These threads are not visible, not like the bright nebulae or the bright explosions of stars, but they are no less important. They are the connections that help the universe form big structures over time. The galaxies, once formed, do not stay still. They move, pulled by the gravity of nearby galaxies, moving to the quiet rhythm of the cosmic web. This movement, once a slow dance guided by dark matter, starts to speed up a little as dark energy takes the lead. The movement of galaxies has entered a new time, where the universe's growth is not a slow, steady step, but a gentle, speeding movement. And so, the stage is set for the next part of the universe's story. The movement of galaxies has begun, and with it, the tale of the universe continues to unfold. In the vast space, the quiet pull of dark energy stretches the ancient light, its wavelengths growing longer as the universe expands gently. This marks the beginning of a new time, the gentle movement of galaxies, linked by the soft threads of dark energy. The stage is set, and with it, the story of the universe continues to unfold. Breath-like winds of interstellar gas begin to stir, signaling the start of creation. These are the basic materials for the birth of stars, gathering and swirling into large, glowing clouds of gas and dust. These nebulae, calm and serene, are the gentle places where stars are born. The process is slow, a quiet dance of gravity and gas. Over millions of years, the gravity of these clouds becomes too strong and they collapse inward. As the gas falls, it warms, and within these swirling places of cosmic fire, the first stars are formed. These stars, the first generation of celestial beings, are large and short-lived, shining with a visible blue-white light. Their lifespan is measured in just millions of years, but in this brief time, they create the materials that will become the building blocks of all that follows. Explosions scatter these materials across the cosmos, spreading the elements of creation. In this vast canvas, new clouds of gas and dust gather, pulled by the gravity of the first stars. These are the second generation, the ancestors of our own sun. They are smaller, their lifespan longer, and they create materials heavier than hydrogen and helium. The gentle movement of stars continues, each generation building upon the last, each explosion a celebration of light and sound, a sign of the universe's endless creativity. As the gentle movement of stars unfolds, so too does the gentle movement of galaxies. They come together and grow, becoming larger and more complex over time. The connections that link the universe together allow big structures to form, creating a web of galaxies made with the threads of dark matter and dark energy. The stage is set for the next part of the universe's story, and the gentle movement of galaxies has begun. The story of the universe continues to unfold, with each new generation of stars and galaxies adding to the cosmic system. The celestial dance of stars unfolds, setting the stage for the next act in this grand cosmic display. The first stars, those massive, brief systems of blue-white light, have scattered their newly formed elements across the cosmos. These elements, like the gentle trails of a comet, connect the universe, weaving a pattern of possibility. And so, the celestial dance of galaxies begins. In the vast, quiet expanse, gas clouds gather, drawn by the gravitational pull of these first stars. They are the second generation, the ancestors of our own sun, smaller and longer lived, their light a sign of the universe's growing complexity. Within these swirling clouds of cosmic warmth, stars are born and fade, each burst a gentle glow, a steady wind that shapes the cosmos. As the dance continues, galaxies grow, merging and combining, their gravitational pull drawing in smaller galaxies, much like a nebula expanding to take in nearby clouds. These cosmic connections link the universe together, allowing large-scale structures to form. The web of galaxies is created, a pattern woven with the threads of dark matter and dark energy. Through this dance, galaxies evolve, changing from simple early spirals into more complex, later-stage ellipticals. Some, like wandering comets, move alone, their paths not tied to others. Each galaxy, a unique cosmic pattern, shares a story of the universe's history, its growth etched into the arrangement of its stars. The celestial dance of galaxies continues, each generation building upon the last, each merge and combination a step in the universe's ongoing system. The cosmic background radiation, the oldest light in the universe, watches this dance, its soft systems traveling through the vast, quiet expanse. The celestial dance of galaxies is a gentle glow of light and time, a cosmic display that has been unfolding since the beginning and will continue until the end. As the cosmic symphony of stars unfolds, vast structures of galaxies take center stage. They are not passive, but active in the cosmic dance, their gravitational pull drawing in smaller companions, much like a comet's tail trailing behind it, weaving patterns in the vast, still expanse. In this celestial ballet, galaxies merge and grow, their connection as close as the interaction of nebulae expanding to absorb nearby clouds. This cosmic interaction is not a gentle waltz, but a steady movement where the gravitational attraction is strong. The dance is slow and steady, taking millions or even billions of years to complete. The cosmic background radiation, the oldest light in the universe, watches this eternal movement. Its presence systems through the vast, still expanse, sharing stories of galaxies forming and changing, of cosmic connections forming and shifting. It is a sign of the universe's ongoing progress, each step marked by the merging and growing of galaxies. These cosmic connections help form large-scale structures. The structure of galaxies is built, a pattern shaped by dark matter and dark energy. Yet, this pattern is not fixed. It changes as galaxies merge and grow, each union a step in the universe's ongoing progress. Galaxies, like the stars they hold, are formed, change, and end. They transform from simple early spirals into complex, later-stage ellipticals. Some, like wandering comets, move independently, their paths not tied to others. Each galaxy, a unique pattern, shows the history of the universe, its changes marked in the patterns of its stars. The movement of galaxies continues, each generation building on the last. The role of black holes, those cosmic helpers, is about to take center stage, their influence shaping the universe's evolution. In the quiet, wide space, a new time begins. Neutrinos, quiet messengers from the early universe, start to move freely, their path not blocked by the energy that once held them. The universe, now 1 second old, is a mix of energy. Electron-positron pairs move and disappear, their short time leaving a burst of light, a flash that fills the newborn cosmos. This is energy interactions, the universe's first big event. As the universe grows, it cools. Temperatures drop, and nucleosynthesis starts. Protons and neutrons, the universe's first heavy parts, begin to come together. Helium-4, the universe's first star, starts to shine in this cosmic mix. The Big Bang's afterglow, the first light of creation, illuminates the universe. Dark matter, the unseen force, starts to shape the cosmos. Gravitational areas form, large empty spaces and tall structures in the cosmic landscape. Galaxies, the cosmos's first groups, begin to form. Gas clouds, large and old, collapse under their own weight. The first stars are born, their light breaking through the darkness of space. This is stellar dawn, the cosmos's first light. The universe expands, its growth measured by the steady increase in distance between galaxies. Supermassive black holes, cosmic guides, take center stage, controlling star formation and shaping the cosmos on large scales. The effect of these changes is profound. The cosmos, once a plain space, is now a mix of light and dark, of stars and empty spaces, of life and change. The cosmic process, once a gentle movement, is now a larger process, each step spreading through the vast, still space. The universe, once a young baby, is now a child, its first steps spreading through the cosmic space. Universe's growth, the first part of the cosmos's endless story, unfolds. As the first light of the Big Bang's afterglow fades, a new cosmic process begins. Cosmic microwave background, the universe's early memory, systems through the vast, quiet space. This ancient radiation, a remnant of the earliest moments, is the cosmos's early memory, a sign of its beginning. Quarks, the universe's first particles, move in the cosmic environment. They move with gluons, their force that pulls them closer, tighter. This movement of attraction leads to the birth of protons and neutrons, the cosmos's first building blocks. Helium-4, the universe's first star, lights up in this cosmic environment, its light lighting the dark. Time passes, measured by the steady rhythm of the expanding universe. Dark matter, the invisible force, begins to shape the cosmos. It creates a pattern of gravity, forming large voids and tall peaks in the cosmic landscape. This movement of dark matter is the early steps in the cosmic process, a pattern that will shape the universe for a long time. Galaxies, the cosmos's first structures, begin to form. Gaseous clouds, vast and ancient, collapse under their own weight. They are pulled together by the gravity of dark matter, their movement like comets trailing through the night. The first stars are formed from these clouds, their light a signal in the cosmic dark. This is the stelliferous dawn, the cosmos's first light. And so, the cosmic process continues. Supermassive black holes, cosmic guides, take center stage. They help form stars, their gravity shaping the cosmos on large scales. They are the universe's early influence, their effect systeming through the vast space. The effect of these processes is deep. The cosmos, once empty, is now a pattern of light and dark, of stars and voids, of life and change. The cosmic process, once a gentle movement, is now a complex pattern, each step systeming through the vast space. The universe, once a young child, is now a mature entity, its first steps systeming through the cosmic night. As we contemplate this cosmic system, we are struck by the universe's complexity. From the simplest particles to the grandest structures, each part plays its role in this cosmic pattern. And so, the process continues, a pattern of light and dark, of life and change, of creation and transformation. This is the universe's ongoing evolution, the first part of its system. In the quiet of space, vast and ancient gaseous clouds begin their movement. These are not just wisps, but large entities, their tendrils stretching far, their cores glowing with possibility. They are the universe's first creators, shaping the cosmos with their gravitational pull, their motions as gentle as comets gliding through the night. These clouds, pulled together by the unseen influence of dark matter, start to gather. They are not simply falling, but being guided, shaped by the gravitational wells formed by this mysterious substance. The effect is clear. Its touch is light as a feather, yet as steady as time. The gathering is a slow, certain process. It is like watching a vast, celestial sundial, the shadow slowly moving toward the base. The gas, once spread thin as a cosmic veil, begins to come together. It is a nebula expansion in reverse, the fabric of the universe tightening, the cosmic fabric becoming denser. At the heart of this tightening, something remarkable happens. The gas, warmed by the compression, begins to glow. The first stars are formed, their light a signal in the cosmic dark. They are not just stars, but cosmic creators, their energy powered by the gathering of the gas clouds. They are the universe's first builders, transforming the raw material of the cosmos into elements that will shape the future. These stars, spread like diamonds across the dark sky, are accompanied by supermassive black holes, cosmic guides. They do not control star formation with a strong hand, but with a gentle, gravitational touch. Their influence spreads through the vast, quiet expanse, shaping the cosmos on large scales. The effect of these processes is profound. The cosmos, once a plain expanse, is now a pattern of light and dark, of stars and empty spaces, of growth and change. The cosmic movement, once a gentle waltz, is now a grand ballet, each step spreading through the vast, quiet expanse. The universe, once a young infant, is now a toddler, its first steps spreading through the cosmic night. As the movement of the stars continues, the universe begins to show its next act. The stage is set, the players are in place. The cosmic stage is about to begin the next chapter, where the movement of the stars gives way to the birth of galaxies. And so, the movement continues, a never-ending ballet of light and dark, of growth and change, of creation and transformation. This is the universe's growing up, the first chapter in its endless story. The universe began to take shape as the first stars, scattered like diamonds across the velvet expanse, started their cosmic dance. These stars, formed from the collapse of gas clouds, were not just celestial bodies. They were cosmic creators, their energy powered by gravity's strong pull. They made the basic materials of the cosmos, which would one day form worlds and eventually life. In this quiet, vast space, other forces were working. Supermassive black holes, silent guides of the cosmic ballet, had a gentle pull of gravity. They shaped the cosmos on a large scale, their effect spreading through the void like ripples on a still pond. The black hole's presence was a subtle yet crucial element in the universe's evolution. As the stars continued their movement, the cosmos began to show its next step. The stage was set, the players were in place. The cosmic curtain was about to rise on the birth of galaxies. But before this big event could happen, a key part was needed: galactic disks, places where stars could be made in large numbers. These disks, swirling arms of gas and dust, were made by the pull of supermassive black holes and the collisions of smaller galaxies. They were the cosmic nurseries where stars were made, their light lighting up the dark space like constellations of diamonds across the night. The process of making stars within these disks was a process of gravity and gas. Clouds of gas, pulled by gravity, would come together, compressing and heating until the pressure was enough to start nuclear fusion. And so, a new star was made, its light a sign in the dark space. The role of supermassive black holes in galaxy evolution is multifaceted. They are not just quiet observers in this cosmic movement, but important players, their influence shaping the structures of the universe. Their pull shaped the cosmos on a large scale, their effect spreading through the void like ripples on a still pond. As the stars continued their movement, the universe started to become more complex, ready to show its next step. In the stillness of the cosmos, a new force began to assert itself. Not the explosive birth of stars, but a more subtle, powerful force: gravity. It was not the gravity of the familiar, the pull of Earth, or the dance of planets around the sun. This was gravity on a scale heretofore unimaginable, a gravity that could bend light and draw stars in. This was the gravity of supermassive black holes. At the heart of every galaxy, a colossal black hole stirred, its event horizon a boundary between the known and the unknown. These leaders, millions to billions times more massive than our sun, were the silent guides of the cosmic ballet. They did not move, yet their influence was omnipresent, a gravitational pull that shaped the very fabric of the universe. Gas clouds drifted, remnants of the Big Bang, waiting for the call of gravity. When they encountered a galaxy, they felt the irresistible tug of the supermassive black hole at its center. The gas clouds began to stretch, to spin, to form a disk. This was the birth of galactic nuclei, the cradles of stars. The disks spun, a cosmic pinwheel, as gas clouds collapsed under their own weight, compressing and heating. In this dance of gravity and gas, stars were born, their light illuminating the dark expanse like diamonds scattered on velvet. But the light was not uniform, not constant. It pulsed, it varied, it responded to the gravity of the supermassive black hole at the heart of the galaxy. The black hole, in its stillness, was not idle. It fed on the gas clouds that wandered too close, drawing them in, absorbing them. This was not a violent act, but a silent, constant one. The black hole grew, its mass increasing, its gravitational pull strengthening. It was a feedback loop, a cosmic Ouroboros. As the dance of the stars continued, the influence of the supermassive black holes became apparent. They shaped the structure of the galaxies, their gravity carving out bulges and bars, their presence determining the rate of star formation. They were not just observers in this cosmic dance, but active participants, their gravity a constant, ever-present force. In this endless ballet, the black holes were the leaders, their gravity the guide, the cosmos their orchestra. And as the cosmic symphony played on, the universe took its next step towards complexity, ready to reveal its next act. As the cosmic pinwheel spun, the cosmic curtain lifted, revealing the next act in the grand ballet of the universe. Gaseous tendrils, Remnants of the early cosmos stretched, contracted, and merged under the strong gravitational pull of the first galaxies. This was not a forceful dance, but a silent, patient one, systeming through the expanse of time. These primordial clouds were not uniform, each a unique cosmic symphony of gas, dust, and dark matter, ready to share their details. They were the cosmic composers, their instruments, the forces of gravity and energy, their scores, the laws of physics. And as they played, the first stars were born, their light piercing the cosmic dawn. In this cosmic orchestra, supermassive black holes were the conductors, their gravity the baton, the cosmos their musicians. They were not passive observers, but active participants, their presence sculpting the structure of the galaxies. As the gas clouds collapsed, their gravity carved out bulges and bars, their influence determining the rate of star formation. Beyond the reach of the supermassive black hole's gravity, smaller galaxies wandered, their own cosmic systems intersecting with those of their larger cousins. This was the cosmic paradox, the final step in understanding galaxy evolution as the influence of mergers and accretion became apparent. Comet tails of gas and stars stretched out, cosmic connections reaching across the expanse, ready to merge, to combine, to grow. The stellar wind of one galaxy swept over another, removing gas, altering its course, its very nature. The gravitational pull of the larger galaxy was irresistible, the smaller one drawn in, absorbed, its identity integrated. Yet this was not a one-way process. The expanding nebula of the smaller galaxy brought fresh gas, new fuel, to the larger one. Its stars, once isolated, now found companions, their light mingling, their lives intertwining. The cosmic background radiation systemed of the past, of the first galaxies, of the first mergers, as the dance continued, systeming through time. In this cosmic dance, mergers and accretion shaped galaxies, driving the formation of complex cosmic structures. The gravitational pull of one galaxy on another, the flow of gas from one to another, the connection of stars once isolated, now united, these were the mechanisms that drove galaxy evolution. And as the dance continued, the universe took its next step towards complexity, ready to reveal its next act. As stellar winds move through space, they carry the systems of the past, the systems of the first galaxies. These winds, created by ancient stars, travel through the void, their paths shaped by the gravitational pull of celestial bodies. They are the cosmic signals, sharing stories of creation and destruction, of birth and death, of the grand movement that forms galaxies. In this space, the expanding nebula marks the start of a new system. A small fluctuation in the inflaton field, a quantum ripple, grows, drawing in matter, shaping it. This is the cosmic seed, the first step in the life of a galaxy. It expands, driven by the repulsive force of inflation, a force so strong it challenges our understanding of gravity. Yet, this is not a force without limits. As the universe cools, the cosmic background radiation begins to share its secrets. The first particles form matter and antimatter, their interaction leaving behind a quark-gluon plasma. This is the cosmic soup, the basic material from which the first stars will form. But what drives this process? What fuels the birth of galaxies? The answer lies in the dark matter. Invisible, it spreads through space, its gravity shaping the fate of galaxies. It is the quiet guide, directing gas clouds, bringing them together. And so, the gravitational collapse begins. Gas clouds, under the influence of dark matter, are pulled by their own gravity, moving inward, compressing, heating, and then star birth. The stellar nursery starts, a process of fusion as hydrogen atoms join, releasing energy, forming the first stars. These stars, the early stars, are large, their lives brief but bright. They end in explosions, their remnants spreading the universe with heavier elements, the materials for future stars. Galaxies, like the large galaxies they are, move through space, their paths crossing. The gas trails of gas and stars stretch out, connections across space, ready to merge, to combine, to grow. This is the cosmic balance, the final step in understanding galaxy evolution. As the process continues, the universe moves toward greater complexity. The stellar wind of one galaxy moves over another, removing gas, changing its path, its very nature. The gravitational pull of the larger galaxy is strong, the smaller one drawn in, joined, its identity shared. Yet, this is not a one-way process. The expanding nebula of the smaller galaxy brings new gas, new fuel, to the larger one. Its stars, once alone, now find companions, their light blending, their lives connected. The cosmic background radiation shares the past of the first galaxies, of the first mergers. The gravitational pull of one galaxy on another, the flow of gas from one to another, the connection of stars once alone, now united, these are the ways that drive galaxy evolution. And as the process continues, the universe moves toward greater complexity, ready to reveal its next step. In the grand system of the universe, the single atom plays a vital role. It is the building block, the fundamental unit, the source of all matter and energy. From the simplest atoms to the most complex galaxies, the atom is the thread that weaves it all together, a system to the beauty and complexity of the universe's grand narrative. In the cosmic ballet, a system of gas begins to coalesce, drawn together by the force of gravity. This is not just a gathering of material, but a symphony of elements, each playing its part in the grand orchestra of galaxy formation. The cosmic dawn breaks, revealing a system of gas clouds, the first dancers in this ancient waltz. The dance begins slowly, the gas clouds stretching and twisting, their forms dictated by gravity. They are not alone in this dance. The cosmic background radiation from the early universe still systems, its presence influencing the gas clouds' movements. This is the massive structure's early stage, a time of growth and preparation. The gas clouds grow denser, their gravity increasing. Within them, the first stirrings of stars are felt. These are not the stars we know, but the protostars, the embryos of future suns. They are born from the stellar womb, a gravitational pull drawing them into existence. The stellar wind of one protostar reaches out, caressing another, shaping it, altering its course. This is not a silent process. The cosmic symphony plays on, the symphony of birth. The protostars grow, their gravitational pull increasing. They begin to sing, their light a cosmic melody. This is the cosmic nursery, where the first stars are born. The expanding nebula of gas around them hums with possibility, ready to give birth to more stars, to grow, to evolve. The dance of the cosmos is not just one of creation. It is also one of destruction and rebirth. Massive structures traverse the cosmos, their systems intersecting. Comet tails of gas and stars stretch out, cosmic connections reaching across the expanse, ready to merge, to combine, to grow. This is the cosmic paradox, the final step in understanding galaxy evolution. As the dance continues, the universe takes its next step towards complexity. The stellar wind of one galaxy sweeps over another, stripping away gas, altering its course, its very nature. The gravitational pull of the larger galaxy is irresistible, the smaller one drawn in, absorbed, its identity integrated. Yet, this is not a one-way process. The expanding nebula of the smaller galaxy brings fresh gas, new fuel, to the larger one. Its stars, once isolated, now find companions, their light mingling, their lives intertwining. The dance continues, systeming through time. The cosmic background radiation systems of the past, of the first galaxies, of the first mergers. The gravitational pull of one galaxy on another, the flow of gas from one to another, the connection of stars once isolated, now united, these are the mechanisms that drive galaxy evolution. And as the dance continues, the universe takes its next step towards complexity, ready to reveal its next act. In the grand system of the cosmos, galaxy evolution is a system to the intricate balance between creation and destruction. From the system of gas to the cosmic giant, the story of galaxy formation is one of unity and diversity, of growth through transformation, of the infinite dance of the cosmos. And at the heart of it all, a single atom, a microcosm of the vast processes that shape galaxy formation and evolution. In the stillness, a system of gas, a cosmic sigh. This is the dawn of galaxy formation, the first stirrings of structure in the vast, unending dance of the cosmos. Gas clouds, mere tendrils of matter in the newborn universe, begin to twist and turn, drawn by invisible forces, the first steps in the cosmic ballet. The universe, just 380,000 years old, has cooled enough for light to break free from the primordial plasma. The cosmic background radiation, a remnant of the Big Bang, permeates all. Yet, it is not alone. Density fluctuations, tiny ripples in the fabric of space-time, left over from inflation, begin to amplify. Gravity, the cosmic glue, takes hold, drawing these fluctuations together, forming the first gravitational wells. Around these wells, gas begins to condense. The gravitational pull is irresistible, like a cosmic sponge, drawing in matter from vast distances. The flow is steady, a stellar wind in reverse, carrying the seeds of stars yet unborn. This is the birth of galactic nurseries, the expanding nebulae that will give rise to the first galaxies. Dark matter, the invisible hand, guides this cosmic waltz. Accounting for 85% of the matter in the universe, it weaves an intricate web, a scaffolding for the structures to come. Its gentle yet relentless gravitational pull draws the gas clouds together, shaping them into the first galaxies. These primordial galaxies are not the large spirals or big ellipses we see today. They are clumps of stars, islands in the cosmic sea, each a microcosm of the vast processes that shape galaxy formation and evolution. Yet they are enough. Enough to seed the cosmos with light, to start the first supernovae, to scatter the stellar winds that will give birth to the next generation of galaxies. The universe's expansion, a slow and steady creep, poses a paradox. How can galaxies form in an expanding universe? The answer lies in the interplay between gravity and expansion. As galaxies form, they begin to move away from each other, their distances increasing with time. Yet, gravity holds them together, creating the illusion of a static universe. This paradox is resolved by the realization that galaxies are not isolated islands, but part of a larger cosmic web, connected by gravity and dark matter. The dance of galaxy formation continues, systeming through time. The cosmic background radiation systems of the past, of the first galaxies, of the first mergers. The gravitational pull of one galaxy on another, the flow of gas from one to another, the connection of stars once isolated, now united. These are the mechanisms that drive galaxy evolution. And as the dance continues, the universe takes its next step towards complexity, ready to reveal its next act. In the expanding nebula, tendrils of gas and dust spread out like soft ribbons, a movement of particles moving in the vast, quiet stage of the early universe. This is the cosmic waltz, where gravity's gentle pull guides the movement, drawing the players closer, shaping them into galaxies that will come later. The dance is not one of stillness, but of stellar birth. The first stars shine like bright lights, their light piercing the cosmic dawn, illuminating the web of gravity woven by dark matter. These are the primordial galaxies, clumps of stars in the cosmic sea, each a small version of the big processes that shape their growth. The movement of stars from these first stars carries the seeds of their kind, scattering them like seeds. These seeds will grow, joining together and growing, forming the next generation of galaxies. The dance continues, an eternal symphony played out over cosmic background radiation that shares stories of the past, of the first galaxies, of the first joining together. Yet the dance is not just one of growth and joining. It is also one of challenge. The universe, driven by dark energy, spreads apart at a faster pace. This is the cosmic paradox. As galaxies form and grow, the universe itself stretches apart, making it hard to keep them together. Galaxies try to fight this expanding cosmos, their pull not enough to stop the spreading. They join together, they grow, they expand, all in a big effort to keep up with the fast spreading. This is the long race, where the finish line moves away as fast as the runners approach. But the dance is not one of failure. For every challenge, there is a way to respond. Galaxies change, grow, their movement of stars carrying not just seeds, but also the knowledge learned from billions of years of growth and change. They become islands in the cosmic sea, strong, flexible, each a sign of the lasting dance of the universe. As the dance continues, the universe takes its next step towards complexity. The role of the smallest parts of matter in shaping the cosmos becomes clear. Explore now the microscopic dance, the atomic movement that underlies the big symphony of galaxy formation and evolution. In the cosmic ballet, the dancers take their places, not on stages, but in the vast expanse of the universe. The curtains, vast sheets of cosmic background radiation, speak of the past, of the first galaxies, of the first mergers. Yet, this is not the beginning of our tale. We join the dance in medias res, for the universe is a timeless symphony, each moment a unique composition in the grand cosmic orchestra. The players here are not humans, nor even stars, but the fundamental building blocks of matter, protons, neutrons, and electrons. These tiny particles, mere specks in the cosmic expanse, are the atoms that compose every star, every planet, every galaxy. They are the dancers, and their dance is one of creation and destruction, growth and decay, on scales both microscopic and cosmic. As the cosmic background radiation speaks, we zoom in, our gaze piercing the vast expanse, diving through nebulae and star fields until we reach the microscopic system. Here, the atoms perform their ballet, their movements governed by the laws of quantum mechanics. They attract and repel, merge and divide, in an intricate dance that mirrors the grand symphony of galaxy evolution. Protons, like tiny suns, hold their electrons in orbit, their gravitational pull a miniature system of the cosmic forces that bind galaxies. Neutrons, silent partners, stabilize the structure, preventing collapse. Yet this dance is not one of stasis. It is a dynamic interplay, a constant state of movement. The atoms merge, forming molecules, which in turn combine to create the building blocks of stars. And as stars are born, so too are galaxies. The dance continues, the atoms' movements reflecting the cosmic dance of growth and change. But the dance is not just one of expansion and growth. It is also one of challenge. The universe, driven by dark energy, expands at an accelerating pace. This is a challenge. As galaxies form and grow, the universe itself stretches apart, threatening to pull them apart. Galaxies attempt to keep up, their gravitational pull not enough to hold back the tide. They merge, they grow, all in an effort to remain connected. This is the system of galaxies, where the finish line moves as fast as the runners approach. Yet, the dance is not one of futility. For every challenge, there is a response. Galaxies adapt, evolve, their stellar winds carrying not just seeds, but also the wisdom learned from billions of years of growth and change. They become islands in the cosmic sea, resilient, adaptable, each a system to the enduring dance of the universe. As the dance continues, the universe takes its next step towards complexity. The role of the smallest units of matter in shaping the cosmos becomes clear. The atoms, in their microscopic ballet, underlie the grand symphony of galaxy formation and evolution. They are the unsung heroes, the silent partners, the unseen forces that drive the cosmos. And so, the dance goes on, the atoms moving in their intricate ballet, the galaxies evolving in their cosmic waltz, the universe expanding in its eternal symphony. And as the cosmic background radiation speaks of the past, of the first galaxies, of the first mergers, it also speaks of the future. For the universe is a timeless symphony, each moment a unique composition in the grand cosmic orchestra. And we, mere specks in the cosmic expanse, are but witnesses to this eternal dance. The cosmic background radiation hums, a tale of deep time unfolds, a dance of galaxy evolution. In the heart of the cosmos, where the first stars flickered to life, the dance began. This intricate interplay of forces was set in motion by the earliest universe, shaped by the unseen hands of dark matter and dark energy. In the wake of the Big Bang, the universe expanded in a cosmic inflation, a period of exponential growth driven by the inflaton field. This rapid expansion, like the first breath of life, was the universe's first gasp of existence. It was here, in these earliest moments, that the seeds of large-scale structures were sown, tiny quantum fluctuations in the infall, the precursors to the galaxies we see today. As the universe cooled, matter and antimatter annihilated, leaving behind a quark-gluon plasma. This primordial soup boiled with potential, ready to coalesce into the building blocks of the cosmos. In this cauldron of creation, protons and neutrons formed, the first atoms of a universe yet to be born. Neutrinos, the remnants of the early universe, decoupled from the rest of the matter, leaving behind a low-energy cosmic neutrino background. They are the silent witnesses, the unseen travelers, their system, a system to the universe's vastness. Meanwhile, electron-positron annihilation released a flood of photons, a cosmic dawn that would light the way for the first stars. Big Bang nucleosynthesis followed, a symphony of nuclear fusion that converted neutrons and protons into the light elements that would become the first star's fuel. In this alchemy of the cosmos, helium and lithium were forged, the elemental foundation upon which galaxies would be built. The first stars, massive and short-lived, ignited the cosmic web. Their explosions, supernovae in the making, scattered heavy elements across the universe, enriching the cosmic soil. This stellar seed was the catalyst for galaxy formation, the spark that would set the universe ablaze with light. In the gravitational cradle of dark matter, gas clouds collapsed, drawn together by their own gravity. This was the birth of galaxies, the first islands in the cosmic sea. They merged, they accreted, they grew, each one a unique composition in the grand cosmic orchestra. Dark energy, the universe's accelerator, drove this cosmic expansion. Galaxies, like runners in a marathon, struggled to keep pace, merging and growing in a desperate bid to outrun the relentless tide. Yet, the dance was not one of futility. For every challenge, there was a response. Galaxies adapted, evolved, their stellar winds carrying not just seeds, but also the cosmic knowledge learned from billions of years of growth and change. As we peer into the heart of the cosmos, we see not just galaxies, but the atoms that underlie them. In the microscopic ballet, these tiny units of matter move in intricate patterns, their dance the unseen force that drives the cosmos. They are the unsung heroes, the silent partners, the unseen forces that shape the grand symphony of galaxy formation and evolution. And so, the dance continues, the atoms moving in their ballet, the galaxies evolving in their cosmic waltz, the universe expanding in its eternal symphony. In the vast, still expanse, we see not just the system of galaxies, but the system of the universe itself, a system that began in the earliest moments of its existence and continues to this day. The cosmic background radiation hums, a reminder of the universe's timeless story, a story of constant evolution, a story that we are all a part of. In the vast, still expanse of the cosmos, a new dance begins. Galaxies, the grand choreographers, weave their tales in the fabric of the universe. The stage is set, not by human hands, but by the unseen forces of gravity and time. In the heart of these cosmic ballets, an important aspect lies hidden. It is not in the radiant stars or the swirling gas clouds, but in the silent, unseen system of dark matter. This is our focus now, for it is a crucial force, the silent partner, the unseen element that shapes the grand symphony of galaxy formation and evolution. Imagine a spherical halo, extending far beyond the visible disk of the galaxy. This is where our story unfolds. In this microscopic system, the distribution of dark matter is not uniform. It is more concentrated towards the outer regions, forming a spherical halo that stretches out, unseen, yet ever-present. This concentration of dark matter is not just a curiosity, but a vital factor. It is the gravitational pull that helps bring gas clouds together, the process that leads to the birth of galaxies. In the early universe, these gas clouds were influenced by early changes, seeds created by the cosmic inflation that preceded them. As these gas clouds come together, they form the first galaxies. The process is not swift, it unfolds over billions of years. Yet, it is this slow, steady process that gives birth to the cosmos we know today. The galaxies change, grow, their winds carry not just seeds, but also the knowledge learned from billions of years of growth and change. The movement of galaxies is not isolated, They are part of a larger system, a vast network of connections. Like comet tails, they move in and out of each other's pull, influencing each other's growth and change. And so, the movement continues. The atoms move in their ballet, the galaxies change in their cosmic waltz, the universe expands in its eternal symphony. In the vast, still expanse, we see not just the system of galaxies, but the system of the universe itself, a system that began in the earliest moments of its existence and continues to this day. In the next segment, the processes behind the formation of galaxy clusters will be explored. For these clusters, too, are part of the cosmic movement, their role important in shaping the structure of the universe. As gas clouds begin to coalesce, drawn together by gravity's gradual pull, the earliest moments of galaxy formation unfold. These primordial clouds, born from the cosmic womb of the Big Bang, are not yet galaxies but promise-filled seeds, waiting for the right conditions to bloom. The inflaton field hums like a cosmic lullaby, driving the earliest expansion of the universe. It is a period of quick growth, a time when the universe itself is a newborn, stretching and yawning into existence. This field, a temporary presence, leaves behind a system in the fabric of space-time that sets the stage for the dance of galaxies to come. As the universe cools, it begins to calm. The active energy of the Big Bang subsides, and matter starts to take shape. Neutrinos, the universe's earliest messengers, decouple from the rest of the matter, leaving a low-energy cosmic neutrino background, a silent witness to the universe's infancy. In this calm, the first stars are born. They ignite like bright lights, their light piercing the darkness of the early cosmos. These stars, the universe's first alchemists, forge the elements that will become the building blocks of galaxies. They are the stellar forges, the cosmic workshops where light and heat sculpt matter into new forms. Galaxies weave in and out of each other's gravitational pull, their trails leaving paths of stars and gas that form new galaxies or enrich old ones. They are not isolated islands in the cosmic sea, but part of a vast, interconnected web. The dance of the galaxies continues. The atoms move in their eternal dance. The galaxies evolve in their cosmic waltz. The universe expands in its eternal symphony. In the vast, quiet expanse, we see not just the system of galaxies, but the system of the universe itself, a system that began in the earliest moments of its existence and continues to this day. But what drives this dance? What is the invisible force that guides the cosmic waltz? To understand the role of dark matter in galaxy formation, we must first grasp how it influences the gravitational potential wells that allow galaxies to form and grow. For dark matter, though silent and unseen, is the invisible force shaping the dance of the galaxies. In the calm after the cosmic dawn, the first galaxies begin their system, tiny seeds of stardust and gas, drawn together by gravity's gentle hand. These are the stellar nurseries, the cradles of light where the universe's first galaxies are born. A mysterious force moves unseen at the heart of this process. Dark matter, the cosmic guide, influences the galaxy's growth. It does not shine, does not glimmer, yet its gravity bends the light of visible matter, revealing its presence through the subtle shaping of space-time. Imagine the gravitational structure of the early universe. Dark matter, like an unseen thread, connects the fabric of the cosmos, creating areas of gravity that attract and concentrate the matter we can see. These areas are the beginnings of galaxies, where the first stars form and the first explosions scatter the elements that will build future stars. As the universe expands, so too do these gravitational areas. They grow, their edges stretching out, reaching for the void. However, the cosmic background radiation, the cosmic rhythm, slows the expansion, halting the growth of these early structures. Yet, the process continues. The galaxies, now formed, begin to interact, their movements shaping intricate patterns in the cosmic sea. They come together, combine, and create new galaxies, enriching the cosmos with ever more complex structures. But what drives this change? What unseen force guides the cosmic movement? To understand the role of dark matter in galaxy formation, we must focus on another cosmic element, supermassive black holes. They too, in their own way, are guides, influencing the growth of galaxies through their gravity and the energy they release. Their movement, like that of the galaxies, is one of constant change, a never-ending pattern in the vast, quiet expanse of the universe. In the cosmic space, where the first galaxies formed, supermassive black holes played a crucial role. They did not create stars themselves, but their influence was vital. Like a gravitational rhythm, they moved at the center of these galaxies, helping them grow and affecting star creation. Imagine the star-making area of a young galaxy. Gas, the material for stars, moved in large clouds. Supermassive black holes, much heavier than our sun, sat at the center, their gravitational force shaping the movement of these clouds. They pulled in gas, using it, but not all of it went into the black hole. Some was moved, redirected, forming a gas movement that slowed the flow of gas into the black hole and, importantly, stopped too much from reaching the galaxy's edges. This process was not passive. Supermassive black holes sent out strong energy, pushing away from their centers. These energies, made of high-energy particles, made spaces in the gas, stopping it from cooling and forming new stars. It's as if the black hole was saying, "Not yet, not too much, not too fast." This is the galactic rhythm, setting the pace of star creation. But what of the gas that did reach the black hole? It moved in, became hot, and shone brightly. This galactic center was a light in space, showing the black hole's effect. And when the gas finally reached the black hole, it moved in quickly, releasing a lot of energy as it did so. This is the black hole's energy release, a strong force shaping the galaxy around it. Yet, this was not a one-way process. The galaxy, in turn, affected the black hole. As stars were made and ended, they added heavier elements to the space between stars. Some of this material went into the black hole, changing its makeup over time. It was a galactic exchange, a back and forth between the galaxy and its central force. This process continued, changing over time. Galaxies joined together, their central black holes coming together in galactic mergers, making even bigger black holes. These large black hole pairs controlled the growth of their combined galaxies, their gravitational forces and energy pushing, setting the pace of star creation again. Thus, the role of supermassive black holes in galaxy growth was not just about using material, but about controlling. They were not the end of a galaxy's story, but a key part of its growth. They were the galactic guides, their unseen influence helping shape the galaxies, forming the universe we see today. In the early universe, where galaxies began to form, forces worked together to shape the cosmos. The universe's early processes, involving gravity and gas, set the stage for galaxy development. Black holes, which form in the centers of stars, grow by pulling in matter. Their gravity influences the galaxies around them, creating a lasting connection. This interaction affects how galaxies form and change over time. Gas falling into black holes heats up and shines brightly, illuminating the universe with their light. When gas reaches the edge of a black hole, it releases energy, affecting the galaxy's surroundings. Galaxies also influence black holes. As stars form and die, they release materials that can fall into black holes, changing their composition over time. This mutual relationship between galaxies and their central black holes is a delicate balance. Over time, galaxies merge, and their black holes combine, creating even larger black holes. These massive black holes help regulate the growth of their galaxies, influencing star formation and shaping their destiny. Supermassive black holes play a key role in shaping galaxies, guiding their development and growth. They are not just consumers, but also regulators, influencing how galaxies evolve and change. The formation of galaxies is a complex process driven by the interactions of forces. This ongoing process continues to shape the universe, creating a constantly changing cosmic environment. The cosmic dawn breaks, and with it, the first galaxies are born. This is not a sudden explosion of stars, but a gradual expansion of nebulae as the universe cools and matter begins to clump under gravity's pull. The movement of the cosmos unfolds. The movement of stars begins with the collapse of gas clouds, seeded by the fluctuations of the early universe. These clouds, once tiny ripples in the fabric of the early universe, now grow, attracting more matter, becoming vast nurseries for stars. They are the sources from which the first galaxies emerge. Galaxies do not form in isolation. The web of the cosmos is woven as galaxies interact, merge, and grow. They are connected by streams of gas and stars, stretching across the vast expanse, their gravitational forces like the currents of a cosmic ocean. Dark matter, unseen but felt, plays an important role in this dance. It is the invisible force guiding the movements of galaxies, providing the gravitational potential wells for stars to be born. Yet, we must not forget the cosmic energy driving the expansion of the universe, allowing galaxies to form and evolve across ever larger scales. Galaxies, in turn, influence each other. Galactic mergers occur as galaxies merge, their central supermassive cores setting the pace of star birth in their combined galaxies. These cosmic forces regulate the growth of their galaxies, their gravitational forces and energetic winds shaping the universe we see today. This movement continues, evolving over long periods of time. Galaxies are not static entities, but living, breathing organisms, their stars born, dying, and enriching the interstellar medium. The background radiation, a system from the Big Bang, serves as an indicator for these galactic evolutions. This segment sets the stage for understanding how galaxies interact and evolve within the broader cosmic framework, leading into the next segment, which will system into specific mechanisms and paradoxes. Galaxies move and interact, their gravitational pulls like the rhythm of an unseen orchestra. They are not isolated dancers, but connected by filaments of gas and stars, stretching across the cosmic stage. This segment focuses on the mechanisms behind galaxy mergers, setting the stage for a deeper exploration of the paradoxes involved in galaxy formation. Nebulae come together, their swirling arms entangled in a cosmic system. These celestial bodies, born from the Big Bang, are drawn together by the force of gravity. As they approach, their shapes start to merge, and the dance intensifies. Stellar winds from each galaxy push against the other, resisting the pull. But the force is too great. Like a cosmic tide, the two galaxies are drawn together, their cores merging in a vibrant display. Supernovae try to slow the process, but it is too late. The galaxies are intertwined, their fates connected. Dark matter, the invisible conductor of this cosmic symphony, plays a critical role in this dance. It is the unseen force that binds galaxies together, providing the gravitational potential wells that allow stars to form. As the galaxies merge, their dark matter halos intertwine, creating a new, more massive structure. The merged galaxy is a dynamic environment where stars are pulled from their orbits, scattered into space, or grouped together in significant changes. But from this environment, new structures form. The merged galaxy begins to settle into a new, stable form, its stars finding a new rhythm in the cosmic dance. This process, repeated countless times throughout the history of the universe, is how galaxy clusters are formed. The merging of galaxies leads to the accumulation of matter, the creation of denser structures within the universe. It is a process that continues today, shaping the cosmic web that stretches across the observable universe. As we system deeper into the mechanisms of galaxy mergers, we begin to understand the role they play in the evolution of cosmic structures. From the first galaxies born in the early universe to the massive clusters that populate the cosmos today, galaxy mergers are the unseen choreographers, orchestrating the growth and evolution of galaxies across cosmic time. The universe, now over 1 billion years old, has grown from the initial burst of inflation, through the hot, dense phase, and into an era where structure begins to take shape. The cosmic neutrino background, a low-energy system from the early universe, has been traveling freely since neutrinos decoupled around 1 second after the Big Bang. This cosmic neutrino symphony, though silent to our ears, leaves an imprint on the fabric of the universe, influencing the large-scale structure we observe today. In this stillness of the cosmos, a phenomenon occurs that will forever leave its mark. Neutrino decoupling, the moment when these particles broke free from the rest of the matter, was not just an isolated event. It was a pivotal moment, a turning point that continues to influence the ages. The neutrinos, now liberated, streamed outwards, their path traced in the cosmic microwave background radiation, the oldest light in the universe. The universe, now a vast cosmic ocean, was teeming with potential. Density fluctuations, seeds of structure planted by inflation, began to grow. Gravity, the force that guides, began to weave its spell, drawing matter together, forming the first galaxies. The neutrino decoupling, though no longer an active force, had set the stage for these celestial formations. Its influence, like the wake of a comet, stretched out, connecting the dots in the structure of the universe. The universe's large-scale structure is a complex system, woven from the threads of neutrino decoupling. This event, though no longer a dominant force, continues to shape the universe's evolution. As we gaze into the cosmos, we see the remnants of a bygone era, the systems of a time when neutrinos first broke free. The universe's secrets, hidden in the depths of space and time, are slowly revealed, one by one. The universe's vast expanse holds many mysteries, and neutrino decoupling is one of its most significant enigmas. This event, a pivotal moment in the universe's history, continues to influence the cosmos, shaping the very fabric of space and time. The universe's large-scale structure is a system to the power of neutrino decoupling, a reminder that even the smallest events can have a profound impact on the universe's evolution. In the vast space, as the first galaxies began to form, a gentle yet meaningful process was about to unfold. Basic building blocks of ordinary matter were not yet joined into atoms, existing instead as a warm, thick mixture that spread through the universe. This mixture was not static, it was dynamic, a quiet flow of particles bumping and moving, driven by the leftover heat from the Big Bang. Energy waves, like soft sounds in the space, moved through this mixture, systeming the differences in density and the early music of the universe. These energy waves were born, not from stars, but from the very space of the early universe, marking the universe's first gentle sounds, a harmony that would shape the large-scale structure of the cosmos. As these energy waves moved, they exerted a gentle force, creating areas of more and less density. This was the early cosmos's first signs of structure, a quiet balance of pulling and pushing, a movement that would shape the future of the universe. Now, about 380,000 years after the Big Bang, something special occurred. The universe grew and cooled, transforming the mixture into a dark, diffuse medium. As it did, it allowed light, the light from the early universe, to travel through the cosmos for the first time. This was the moment when the universe became clear, and light could move without barriers. The energy waves, those residual vibrations of sound, did not cease immediately. They continued to move through the universe, exerting their influence, leaving a quiet mark on the cosmic stage. This segment systems into the mysteries behind baryon acoustic oscillations, focusing on the secrets they reveal about the universe's history. The universe, in its quiet stillness, continues to share its knowledge, one gentle sound at a time. The mark of these early energy waves, now seen in the spread of galaxies, serves as a gentle reminder of the universe's earliest moments, guiding us back to the cosmos's origins. As light trails of illumination spread across the cosmic expanse, the universe expanded, and with it, the seeds of galaxies began to take root. Approximately 380,000 years after the Big Bang, the radiation of light carried by the cosmic background traveled across the cosmos, illuminating the first structures to emerge from the primordial soup. These structures, the result of tiny fluctuations that occurred during expansion, were the first signs of what would become the large-scale structures we see today. As the universe continued to grow, so too did these structures, creating regions of higher and lower density. The universe, once a hot, opaque soup, started to cool and allow light to travel through its vast space, marking the cosmic dawn, the moment when the universe became transparent and light could move freely. Expansion of nebulae began to take hold, leaving a pattern on the cosmic expanse. The acoustic energy did not disappear immediately. It continued to move through the universe, shaping the early cosmos. Approximately 13.8 billion years later, we stand at the beginning of understanding the mystery at the heart of galaxy formation. For as galaxies formed through gravitational forces, driven by the presence of dark matter, the universe simultaneously expanded at an increasing rate, pushed by dark energy. This movement of attraction and repulsion, of formation and expansion, is the central mystery of our universe. Galaxies, shaped by the gravitational forces of dark matter, grew and changed over billions of years. They joined together, gathered gas, and formed stars in a process that continues to this day. Yet, as they grew, the universe around them expanded at an ever-increasing pace, a quiet, invisible force driving galaxies apart. The universe, in its vast space, continues to reveal its secrets, one pattern at a time. The imprint of these early patterns, now frozen in the distribution of galaxies, serves as a guide of knowledge, carrying us back to the earliest moments of the cosmos and into the heart of the cosmic mystery. In the quiet movement of the cosmos, light from the first star softly moves through space, following the pattern of creation. As the universe grows, so does our knowledge of its earliest moments, recalling the time when the building blocks of galaxies were formed. At the center of this cosmic movement lies the single atom, a tiny part in the large picture, yet a major part in the story of the universe. Here, we explore, leaving behind the familiar and moving into the wide space of deep space. In this place of gentle quiet, the universe is not empty but a place of possibility, painted with the soft strokes of tiny energy changes. These cosmic energy waves, created in the early growth of the universe, leave their mark on the background of space, showing the universe's earliest moments. About 380,000 years after the Big Bang, the universe became clear. The energy waves, those gentle movements of energy, did not stop right away. They continued to move through space, leaving their mark on the cosmic stage, a space wind carrying the essence of creation. But the story of the universe is not about stillness, but about movement, about forming and growing. As the universe grew, so did the atoms within it, coming together to form the first stars. These stars, made from the remains of the Big Bang, were the start of galaxy forming. About 13.2 billion years after the Big Bang, the first galaxies began to form. Drawn by the pull of dark matter, gas clouds came together, creating the first celestial bodies. These galaxies, in turn, were the start of star forming, their space winds carrying the seeds of future worlds. Even as galaxies formed, the universe itself grew faster, driven by the mysterious force of dark energy. This balance between pulling and pushing forces, between forming and growing, is the mystery of our universe. In this part, we examine the atomic level, focusing on the smallest parts of the universe. The single atom, in its quiet stillness, holds the key to understanding the universe's growth, from the first stars to the galaxies that fill the cosmos today. The universe, in its quiet, unseen movement, continues to share its secrets, one gentle mark at a time. The mark of these early energy waves, now frozen in the spread of galaxies, serves as a space wind of knowledge, taking us back to the earliest moments of the cosmos and into the heart of the universe's mystery. This part, like the universe itself, is a system into the unknown, a gentle movement of discovery. In the quiet space, galaxies move and change, part of a process of forming and evolving. The universe, vast and still, is made of light threads, showing how it keeps growing. These threads weave together, forming a system of stars, galaxies, and space. Galaxies form from the Big Bang's leftovers, shaped by gravity from unseen forces. These forces, invisible to our eyes, guide the universe by pulling gas into stars, those visible markers of creation. As galaxies take shape, the universe itself undergoes a transformation. A network of galaxies begins to form, stretching into space, guided by early universe clues, systems of the first conditions that started everything. Stars form in these early galaxies, their lives connected to their home galaxies. They shine brightly, their light showing existence. When they end, they leave materials for new worlds and galaxies. The universe, in its quiet, unseen process, continues to evolve, shaping the cosmos. Even as galaxies formed and grew, the universe expanded faster and faster. Dark energy causes the universe to stretch, leaving faint systems of early sounds in how galaxies are spread out. This expansion, this ongoing change, is a mix of pulling together and pushing apart, forming and breaking down. Galaxies come together by gravity, only to be pulled apart by the universe's growth. It is a process that has happened for billions of years, continuing today. These early sound systems, now part of how galaxies are spread out, help us learn about the universe. They show the secrets of the cosmos, one clue at a time. The universe, in its quiet, unseen process, keeps sharing its secrets, one clue at a time. In the quiet space, the cosmic background radiation, a gentle glow from the beginning of time, shimmers like a soft light. This gentle glow, a memory of the Big Bang, holds the marks of the first structures in the universe, the first galaxies. Their creation, a movement of gravity and gas, is a brief moment in the universe's long system. As the universe cooled and grew, early gas clouds, influenced by changes from the early expansion, began to gather under their own pull. This gathering, like the slow, steady movement of ancient mountains, marked the start of galaxies. They were not yet the grand spirals or large shapes we see today, but rather the simple beginnings of the cosmic family. A cosmic breeze carried the memories of the early universe, its gentle caress systeming the light of the first stars. These early stars, formed in the place of the universe's youth, were the universe's first transformers, changing hydrogen and helium into the heavier elements that would become the building blocks of life. As these stars ended, they left behind their remnants, creating a cosmic cloud of elements. This cloud, a vast, intergalactic space, would lead to the next generation of stars and galaxies. The universe, in its quiet, unseen movement, kept changing, its growth marked by the movement of cosmic tides. Even as galaxies formed and grew, the universe itself stretched at a steady pace. Driven by the mysterious force of dark energy, the cosmos expanded, its calm broken only by the faint marks of the early universe, those early changes stored in the spread of galaxies. This expansion, this cosmic movement, is a mystery. It is a delicate balance of pull and push, change and transformation, all in one. Galaxies formed, pulled together by gravity, only to be separated by the steady expansion of the universe. It is a movement that has been happening for billions of years, a quiet pattern that continues today. The mark of these early changes, now stored in the spread of galaxies, serves as a gentle guide of knowledge. It leads us back to the earliest moments of the cosmos, to the heart of the cosmic mystery. It shows the secrets of the universe, one gentle change at a time. This segment introduces careful observation methods, moving into a focus on specific findings and their meaning. As we system deeper into the cosmos, we find that the more we learn, the more we realize how much more there is to learn. The universe, in its quiet, unseen movement, keeps revealing its secrets, one gentle change at a time. In the quiet, vast expanse, a cosmic dance begins. Like a gentle breeze stirring a nebula, the universe's early expansion sets the stage for the birth of galaxies. This is not the sudden, explosive creation of stars, but a subtle, patient process, a cosmic system that systems through eons. Gravity takes the lead in this silent ballet, drawing together primordial gas clouds, the first waltz of matter in the universe. These clouds, vast and cold, are the seeds that will grow into the first galaxies. As the universe expands, so too does the dance of these gas clouds. They collide, merge, and separate, a cosmic tango that stretches out over billions of years. This growth, the cosmic expansion that gives rise to the galaxies we see today, is a paradox. Galaxies form, drawn together by gravity, only to be pulled apart by the relentless expansion of the universe. The dance, this silent symphony, is the heart of the cosmic paradox. The intricate pas de deux of galaxy mergers and accretion is a segment that focuses on the intimate connections that shape the structure and evolution of galaxies. These are the stellar winds that carry gas from one galaxy to another, the cosmic connections that paint the night sky with stardust. Galaxies, like vast cosmic artists, use these mergers and accretion to create their masterpieces. They take in gas, stars, and even entire galaxies, growing and changing with each cosmic encounter. This is not a violent process, but a gentle, patient one, a cosmic system that systems through time. In the stillness of the universe, these mergers and accretion are the gentle rustling of leaves, the soft hum of bees in a garden. They are the quiet, unseen forces that shape the cosmos, the cosmic background radiation that carries the systems of the early universe. This segment is not about the grand dance of the universe, but about the mechanisms of galaxy mergers and accretion, setting the stage for a deeper exploration of their impact. In the vast, still expanse, galaxies paint their masterpieces with mergers and accretion. These are the gentle, patient systems that system through time, the quiet forces that shape the cosmos. It's a dance, a silent symphony, where galaxies take in gas, stars, and even entire galaxies, growing and changing with each encounter. At the heart of this cosmic ballet lies a difference. The universe expands, driven by dark energy, yet galaxies form, drawn together by dark matter's gravity. How can the universe's steady expansion coexist with the gravitational pull that brings galaxies together? This is the central question, the ongoing mystery at the core of galaxy formation. Galaxies form in the cosmic equivalent of a gentle rain, a nebula expansion. Gas clouds, under the influence of dark matter, collapse under their own gravity. Stars ignite, their light painting the canvas of the early universe. Yet, even as the universe grows, so do its galaxies, defying the steady expansion. This cosmic difference is evident in the gentle systems of galaxy mergers and accretion. As two galaxies collide, their stars intertwine in a cosmic waltz. Gas is exchanged, stars are born, and the galaxies grow, their shapes forever changed by the encounter. Yet, even as they merge, the universe continues to expand, a silent, invisible force pulling them apart. The universe's expansion, facilitated by dark energy, seems at odds with the gravitational pull that draws galaxies together. It's a difference, a cosmic contrast. And it's a question that continues to intrigue even the most brilliant astrophysicists. This segment addresses the central difference of galaxy formation, concluding the documentary on a note of ongoing mysteries in astrophysics. The universe's expansion, driven by dark energy, both facilitates and contrasts galaxy formation. It's a cosmic puzzle, a difference that continues to intrigue and inspire, a system to the vast, still expanse of the cosmos and the mysteries it holds.